text. It offers tools for tasks like tokenization, partial switch tagging, phrasing, and semantic reasoning. So objectives of NLTK are create a chatbot that can learn and adapt over time. So use NLTK and machine learning to process natural language and improve over time based on user interactions. So coming to next slide. So key concepts. What is NLTK? NLTK stands for Natural Language Toolkit. It provides access to text processing libraries and datasets for NLP tasks. So common features are tokenization, stemming, lemmatization, process tagging, praising, and more. So types of chatbot. So there are many types of chatbots. For example, rule-based chatbots. Rule-based chatbots are the chatbots which follow the predefined rules to respond to specific input. So AI-based chatbots. AI-based chatbots are a type of chatbots use machine learning and NLP to interrupt and respond to more complex and varied information inputs. So next is self-learning chatbots. Continuously improve by learning from previous interactions and user feedback. So self-learning chatbots means they learn on previous inputs and they follow the user inputs and they give the output based on the previous feedback. So coming to the next slide, system architecture. The system architecture of chatbot built by using Flask and NLTK, integrating natural language processing techniques and self-learning mechanism. So first one we used is front-end interface, user interaction layer. We used HTML, CSS, and JavaScript. Role of this front-end interface are provides a dynamic interface for user to interact with the chatbot, and users can send queries and view responses in real time. So in backend API, we use Flask application. Technologies are Flask means Python micro web framework. So role is acts as a central controller, managing the flow of data between the front end, the knowledge base, and the NLP processing layer. So next coming slide is components of the self-learning chatbot using natural language toolkit. So when there are many components, the first one is text pre-processing. So text pre-processing means, so first step is tokenization, means breaks down user input to individual word or tokens, means breaking down a word sentence into different words or tokens. So next step word removal eliminates common words, means example the, he, the, is. Step word removal, so it's eliminate the common words uh, to focus on meaningful parts of this query. Next one is lemmatization. Reduces words to their base or root form. Okay. Next is synonym expansion. Uses wordnet to identify synonyms for keywords in the query. Next is similarity matching. So if a word we give input to the chatbot, so it identifies the similar words. Many are there similar words, means synonyms like that. So it will identify that and it will compare all the queries related to that similar word. Next is knowledge database layer.
So coming to the flow of interaction, first is user input. The user enters a query into the chatbot interface. So here the interface is HTML or JavaScript frontend. Next, coming to Flask API, the queries is sent to the Flask server, triggering the NLP processing pipeline. Next is the NLP processing. Here the tokenization, stop word removal, and lemmatization cleans the input by giving the words the necessary adjustment. Here the synonym expansion increase the query flexibility. Next is the knowledge base search. Flask queries the JSON knowledge base for closest matching question. If a match is found, a response is returned. Next, coming to learning and response. If no match is found, the user is prompted for an answer, and then the new query answer pair is stored in the knowledge base for future use. Coming to the technologies used, programming language is Python for backend and NLP integrated for the processing. NLP library here, NLTK Natural Language Toolkit for text processing, synonym expansion, and similarity matrix. Database is JSON for storing and updating question answer pairs. Framework for Flask for backend operations and API handling. Frontend HTML, JavaScript, and CSS for user interface. WordNet for synonym expansion. Tools IDEs, that is PyCharm, Visual Studio Code, and Git for version control. Deployment web servers and or cloud for platforms such as AWS. Dialogue management. Dialogue management is a critical component in chatbot development. We need to ensure meaningful and coherent communication between the chatbot and user, such that so that we need to involve here involves the managing of flow of conversation, understanding user input, and generating appropriate responses based on context. Stateful or versus stateless chatbots. Stateful retains context from previous interaction. For chatbot performance evaluation. Accuracy of intent recognition. It measures how accurately the chatbot identifies the user's intents. Evaluated using metrics like precision, recall, and F1 score. Response relevance. It determines whether the responses are contextually appropriate and helpful, often assessed through user feedback or expert review. Error rate tracks the frequency of errors such as incorrect responses or misunderstood queries. Includes metrics like false positives and false negatives. Task completion rates measures the chatbot